Good morning. In today's class, we'll learn about binary search trees. So, how to search a element in binary? So, how to search a element in a binary tree? So, to search with the element in a binary tree, we'll start with the root and compare all the elements in the root, then level 1, then level 2, then level 3, like that the comparison goes on. So, what is level here? So what is level here? Level is nothing but we say that the root node is always at level 0, then its immediate children are at level 1, then its immediate children are level 2, and its immediate children are level 3, and so on. So how to search a element in a binary tree? So we'll start comparing with the root, that is level 0. If they are equal, we say that the search is found. If they are not equal, then we go to level 1 and compare the elements in the level 1, and then we'll compare the elements in the level 2, and the process continues. So do you think this is better than searching a linked list? No, because this will take big O of n time. That is, we are comparing each and every element of the binary tree, and it is more time consuming. So we go for one more simplest technique called as binary search tree. So binary search trees has a property that the value stored at a node is greater than the value stored at its left child and less than the value stored at its right child. Now if you see this diagram, the first element is the root element, and all the elements to the left side of the root or left subtree are less than the root, and all the elements to the right side of the root are greater than the root. Now I have written here, this is the left subtree. You can see the dots. I have divided the tree into two disjoint sets here. One is the root, second is the left subtree, and the third is the right subtree. I have marked here. Then all the elements or the values in the left subtree are less than the root, and all the values to the right subtree are greater than the root. So this is the property of binary search tree. So binary search tree has the property that all the values stored at the node is greater than the value stored at its left child and less than the value stored at its right child. Now I have to search in the binary search tree. I have to search the element in a binary search tree. So if I have to find the smallest element, so where is the smallest element stored? The smallest element can be found in the leftmost part. Leftmost part is this, that is, it is found in the left subtree. And where is the largest element found? The largest element will be found in the rightmost or right subtree. Why is this concept used? Because binary search tree has a property that all the elements will be lesser than the root node. In the left side, all the elements will be lesser than the root node, and to the right side, all the elements will be greater than the root node. Now we will see how to search an element in a binary search tree. So in a binary search tree, we will start at the root. We will compare the value you are searching for with the value in the root. If they are equal, then we say that the search is successful, the element is found. If they are not equal, then again we have to follow two steps here. That is, we have to check whether the value which you are searching for is greater than or less than the root. If it is less than the root, then you have to search only the left part or left subtrees. If the value is greater than the root, you have to search the right part of the tree. So you can see, if the value is less than the value stored at the root, then search the left subtree. If it is greater than the value stored at the right of the root, then search the right subtree. And repeat the steps 2 to 6 for the root of the subtree chosen in the previous 4 or 5. That is, if you are in whichever node you are choosing in the step 4 or 5, then apply the same technique from 2 to 6. Now, is this searching better than searching in a linked list? Yes, because this will take big O of log n time. Now consider, for example, I will take one example and search a element in a binary search tree. Now assume that this is a binary search tree. Now I have to retrieve the element 18. That is, I have to search whether this 18 is found in this binary search tree or not. I am searching for 18 in this binary search tree. So first step, I should compare the searching element. The first step is I have to compare the search element with the root. So 18 is compared with 17. Are they equal? No, they are not equal. So what is the next step? In the next step, I have to check whether the root element is greater than or less than the search element. Here the search element is 18 and root is 17. So the searching element is greater than the root element. 18 is greater than 17. Hence, you have to move to the right part of the array. You have to start searching from the right side of the root. Now, you can see here in the next step, you can see here I am searching in the right side of the tree. I am comparing 18 with the root. Now 20 is the root here. Now 18 is compared with 20. Are they equal? They are not equal. Next, what I am doing, I am checking whether the search element is greater than or less than the root element. Here the search element is less than the root. So what I should do? I should check only the left part or left subtree. So in next, I am in the third step. I am checking. You can see here. I am moving to the left subtree and comparing the element. Now 18 is the root, and I am comparing the search element 18 with the root. Are they equal here? Yes. 18 is equal to 18. That is, search element is equal to root. Hence, we are saying that the search is successful. This is the concept which is used in the binary search tree. So what is a binary search tree? In a binary search tree, all the elements are, if you consider an element as a root element, all the elements to the left side of the root are lesser than the root, and all the elements to the right side of the root are greater than the root. This is the property of binary search tree. And to search for an element in a binary search tree, we have to start comparing from the root. If it is compared element is equal to the root element, we say the search is successful. Else, if the compared element is less than the root, we will move to the left side of the array, left side of the tree, and search in the left part of the tree. If the search element is greater than the root element, we will move to the right part of the tree and search the element. This is the concept used in binary search trees. This is how the element is searched in binary search trees.